Hello students, this is a video on the QA topic test available on the Bodhee Prep app. The how to use this test is you once you've completed the basic concepts of a test and you think you have done some practice, you can take the test on the topic and understand whether you're able to apply the learned concept in an exam mode or not. Once you take a test, there is a video with every test. The video gives you the solutions, of course, and a brief analysis of how you should have attempted the test in terms of time and in terms of attempts. Moreover, there are 200 such topic tests that are available on the Bodhi Prep app. The link for the app is in the description below. So make sure you download the app and make the most of these tests. This video talks about the topic logarithm, and this is the second test on the topic that we're discussing in this video. Overall, the test was probably moderate to difficult level uh, in terms of level of difficulty. 5 to 6 or 6 to 7 questions net correct would mean that you get a 95 plus percentile for sure. The attempt time also would be in the range of about 20 to 23 minutes. That is going through all the questions and finding those 6 to 7 questions that will get correct. If we look at the questions, sum of two numbers a and b. So a plus b is root 18 and their difference a minus b is root 14. Obviously, I cannot do anything with the roots. So we have to find the value of log of a to the base b. So first of all, let us remove the roots by squaring. A plus b whole squared is equal to 18, which means a square plus b square plus 2ab is equal to 18. And a minus b whole squared is equal to 14, which means a square plus b square minus 2ab is equal to 14. A square will not help me. I would rather work with the AB terms. If this is equation 1, this is equation 2. I am subtracting 2 from 1. So a square cancel, b square cancel, 2ab minus of minus 2ab will give me 18 minus 14, which means 4ab is equal to 4 or ab is equal to 1. Now what we do is we take the log on both sides to the base b. Log of ab to the base b is equal to log of 1 to the base b. Log of anything which is 1 is 0 and log of AB is nothing but log of A plus log of B. This will be 0 right hand side. Further, log of B to the base B will be nothing but 1 and therefore log of A to the base B can be written as minus 1 and that becomes my answer. I will call this question a difficult question, though the attempt time once you crack it should not be very high. But going from root to the value AB is not something that might strike upfront, and some amount of hit and trial will be required in terms of how to go about the question. Log of if A is log of 1024 to the base 343, B is 49 to the log of 49 to the base 81, C is log of 25 to the base 16, D is log of 9 to the base 4. What is the value of the product A, B, C, D? So A can be written as log of 1024 upon log of 343. This is nothing but log of 2 to the power 10 upon log of 7 to the power 3. And therefore A becomes 10 by 3 log 2 by log 7. If you look at B, B can be written as log of 49 upon log 81. Log 49 is log of 7 squared. Log 81 is log of 3 to the power 4. This becomes 2 log 7 upon 4 log 3. If you look at C, log of 25 by log of 16, log of A to the base B is log of A upon log of B, which is log of 5 squared upon log of 2 to the power 4. So 2 log 5 upon 4 log 2. Finally, log of 9, D is equal to log of 9 to the base upon log of 4. Log of 9 is 3 squared. Log of 4 is 2 squared. So 2 upon 2 cancels out, log of 3 by log of 2. And therefore, if we find A, B, C, D, the product, this will be 10 by 3 log 2 log 7 upon B will be 2 by 4 log 7 upon log 3. C will be 2 by 4 log 2 by 4, 2 by 4 is there twice. Log of 5 to the upon log of 2. And finally, log of 3 to the base upon log of 2. D. log of 7 cancel, log of 3 cancel, log of 2 cancelled. 2 twos are 4 cancelled, 3 is there, 6 is there. 2 twos are 4, 2 fives are 10. So we are left with 5 by 6, 5 by 6, log of 5 upon log of 2. Since the options are not matching, this is obviously not the answer, this is not the answer. One of these two has to be answer. So what we do is we write this as log of 5 to the power 5 upon log of 2 to the power 6. Log of 5 to the power 5 is nothing but 5, 25, 125, 625, 3125. Log of 2 to the power 6 is 2, 4, 8, 16, 32, 64. Log of b upon log of a is nothing but log of b to the base a. So log of 3125 to the base 64. Option C becomes the answer. I think this is a easy question because basic definitions of log are being used, basic properties of log are being used, and we are not expected to make too many rearrangements. Most of the terms cancel out, so about 2 to 2.5 minutes to solve. But in terms of level of difficulty, it's an easy question. 5.55 to the power x is equal to 0.555 to the power y is equal to 1000. Find the value of 1 by x minus 1 by y. So what we do is we write 5.55 to the power x is equal to 1000, taking uh, log to the base 10. We will get 1000 to the base 10 will be 3. So this becomes x into log of 5.55 is equal to, this is 10 cubed, so 3, which means 1 by x, taking x here will be nothing but 1 by x. Log of 5.55 upon 3. X goes down, 3 goes down. Similarly, 0.555 to the power y is equal to 1000 if we take the log by an exact similar method, taking log to the base 10. Since the base is 10, we don't need to write it down. This becomes y into log of 0.555 is equal to 3, and therefore 1 by y will be nothing but log of 0.555 by 3. Now we have to find out 1 by x minus 1 by y. Because both have denominators, see, this will be log of 5.55 minus log of 0.555 upon 3. Log of a minus log of b is nothing but log of a upon b. This comes out to log of 10 upon 3. Since the base we have taken 10 so far, log of 10 by 10 will be 3, and therefore 1 by x minus 1 by y becomes option C. 1 by 3 is the answer. Easy question. Just take the log and from there put the values. Should not take more than a minute and a half to solve. X is log of 7 to the base of cube root of 3. Y is log of 3 cube root of to the base cube root of 7. We will find the value of the product x and y. X can be written as log of 7 upon log of cube root of 3. This is nothing but log of 7 upon log of 3 to the power 1 by 3. This becomes log of 7 upon 1 by 3 log of 3, and therefore the value of x will be 3 log 7 by log 3. If you look at y can be written as log of 3 upon log of cube root of 7, which will be log of 3 upon log of 7 to the power 1 by 3. 7 to the power 1 by 3, not base, which means y is equal to log of 3 upon 1 by 3 log 7, which means y will be 3 times log of 3 by log of 7. We have to find x into y. So 3 log 7 by log 3 into 3 log 3 by log 7. Log 3 and log 7 cancel out. We're left with 3 into 3, which is 9. So the required product of x and y for us here will be 9. I think an easy question. You just have to put values or calculate values and multiply. Should not take more than a minute and a half. Wx, y, z are natural numbers, 1 to infinity. Log of x to the base y is 3 by 2. Log of z, the w to this z is 5 by 4. Y minus z is 9. From here we can say y raised to power 3 by 2 is equal to x and z raised to power 5 by 4 is equal to y. So z should be a number for which we can take the fourth root. Now the smallest number which gives us a fourth root is 2. 2 raised to power 4 is 16. So if we take z as 16, we can write here 2, 4, 8, 16. 2, 4, 8, 16. This is w. Z raised to power 5 by 4 is w. So if we take z as 16, we will have z raised to power 5 by 4 as 16 raised to power 5 by 4, which is 16, 1 by 4, 5, which is 2 raised to power 5 or 32. And therefore w becomes 32. If z is 16, w is 32. Again, I'm just looking at values and then eventually look for the answer. Now, if z is 16, y has to be 25. If y is 25, 16 plus 9, y raised to power 3 by 2 will be equal to y raised to power 1 by 2 cube, which is 25, 1 by 2 cube, which is 5 cube, which is 125. And therefore, these two numbers satisfy the given conditions. If we take z as 16, we have a y which is 25. And from there, we can find out the value of x and w, which comes out to 125. This was x. So this, which comes out to 125 and 32. 125 minus 32 will be nothing but 93. 125. And therefore, that is one of the options. That becomes my answer. I'll say this is a difficult question because at the end of the day, you'll have to put values and solve, or you'll have to find values for a given equation. Luckily, we were working with the fourth root, and therefore, uh, we got the value at the first answer. It may not happen always because we might end up with a value here of z which does not give us a value of y for which we can take a square root. And so we'll have to find further values. And therefore, I'm saying difficult. And if we have to check for values, obviously time increases for every value that we have to check for. Find the number of digits in 144 raised to power 80. Log of 2 and log of 3 are given. Let 10 raised to power x is equal to 144 to the power 80. This can be written as 144 is 16 into 9. 16 into 9. 16 is 2 raised to power 4. 2 raised to 2 into 3 square raised to power 80, which will be 10 raised to power x is equal to 2 raised to power 320 into 3 raised to power 16. Take the 160. Taking a log of log to the base 10 on both sides, we write this as log of 10 raised to power x to the base 10 is equal to log of 2 raised to power 320 into 3 raised to power 160 to the base 10. This becomes x log 10 of 10, 10 to the base 10, which is 1. This becomes log of 2 to the power 320, log of a into b is log of a plus b. Log of 3 raised to power 160. This becomes 320 log 2 plus 160 log 3. The values of log 2 and log 3 are given. 320 into 0.3010 plus 160 into 0.4771. 320 into 0.3010 will be 9632. 90 x is equal to 96.32 and 160 into 0.4771 will be 76.32. I'm using the calculator for the second calculation, 76.336. 76.336. Yes. 76.336 plus 96.32 will give us x as 160, 170, 172.656. And therefore 144 raised to power 80 is nothing but 10 raised to power 172.656. Now we know that anything which is 10 raised to power 1 to just less than 10 raised to power 2 has two digits. Anything that is 10 raised to power 2 to just less than 10 raised to power 3 has three digits and so on. And therefore, anything that is 10 raised to power 2 point something will have three digits. So what we do is, from here we find the least integer function greater than or equal to this. And therefore, 144 raised to power 80 will have 173 digits. The integer next or just greater than the power of 10 will be the number of digits, because 10 raised to power 172 has 173 digits, 1 and then 172 zeros, till it reaches 173, the power, where the number of digits becomes 174. So 173 becomes my answer. I will call this question easy question, because this is a standard process. If you've done log, you would have done this question, and the process is something that does not change. So attempt time might be higher depending on the calculation involved, but 2 to 2.5 minutes, easy question. N is greater than 1, we have to find the product of log of n, 1 upon log of n to the base 2 plus 1 upon log of n to the base n into 1 upon n log of n to the base 32 plus 1 upon 120 to the log of 120 to the base n. Simplify this. This is written as 1 upon log of n upon log of 2 plus 1 upon log of 8 plus log of n. Writing this will take time. Once you realize what step we are following, visualizing it is a lot easier. 1 upon log of 128 upon log n. We take the reciprocal in each case, log of 2 upon log n into log of n upon log 8 into log of 32 upon log n into log of n upon log of 120. Log n, log n, log n, log n cancel. This is log of 2 into log of 32 will be nothing but 5 log 2, because 32 is 2 raised to power 5. Log of 2 raised to power 5 is 5 log 2. 2, 4, 8, 16, 32. Upon log of 8 will be 2 cubes, so 3 log 2. And log of 120 will be 2, 4, 8, 16, 32, 16, 128. 128 is 2 raised to power 7. This will be 7 log 2. Log 2 is cancelled. We are left with 5 by 21. Option D becomes my answer. Again, from log we are going to ln, which should not have happened in any case. And therefore D is my answer. Again, breaking down the 2 and getting it in the form where n and 2 are in the numerator and denominator might take some time to figure out. Therefore, I am saying moderate difficulty. 1 by 3 log of m to the base 3 plus 3 log of n to the base 3 is equal to 1 plus log of 5 to the base 0.008. First, let us deal with this term. This can be written as log of 5 to the base 8 upon 1000. This is nothing but log of 5. 8 means 2 by 10 into 2 by 10 into 2 by 10. 2 by 10 is 1 by 5. So 1 by 5 raised to power 3. Which means this is nothing but log of 5. And here we have 5 raised to power minus 3. And therefore this can be written as minus 1 by 3 log of 5 to the base 5. Which will be nothing but minus 1 by 3. So this term here is minus 1 by 3. So we can say 1 by 3 log m to the base 3 is equal to plus 3 log n to the base 3 is equal to 1 minus 1 by 3. This means 1 by 3 log of m to the base 3 plus 3 log n to the base 3 is equal to 2 by 3. multiplying by 3 throughout, log of m to the base 3 plus 9 log of n to the base 3 is equal to 2, which can be written as log of m into n to the power 9 to the base 3. 9 goes to the power, so this becomes log of n raised to power 9 to the base 3. Log of a plus log of b is log of a into b. This is equal to 2. And therefore m into n raised to power 9 is equal to 3 square, which means m into n raised to power 9 is also 9, which further means n raised to power 9 is equal to 9 by m. Option B clearly becomes my answer. Again, moderate level of difficulty. Just the base for the right hand side was to be figured out. From there, it becomes a straightforward question, 2 to 2.5 minutes to solve. Find the sum of all possible values of x if log of 20 plus log of x square plus 5x upon log of 4 root 5 is 2. Log of 20 plus log of x square plus 5x can be written as 2 into log of 4 root 5, which can be written as log of 20 plus log of x square plus 5x is equal to log of 4 root 5 squared. So the square of 4 root 5 will be 4 square 16 into 580 log of 80. And therefore log of x square plus 5x can further be written as log of 80 minus log of 20, bringing log of 20 on the right hand side. Log of a minus b, log of a minus log of b is equal to log of a by b. So this becomes log of 4. And therefore x square minus 5x will be equal to 4, which means x square minus 5x minus 4 is equal to 0. All the possible values of x will be the roots of this equation, say alpha plus beta. This is plus, this is plus, this is plus. Alpha plus beta will be nothing but minus b by a, and therefore sum of values becomes minus 5. Again, I think a relatively easy question, easy to moderate at best, not more than 2 minutes to solve. Find the sum of the first n terms of the series. The series is log of x square plus log of x raised to power 4. Just a second. Start. The series is log of x square plus log of x raised to power 4 upon y cube plus log of x cube upon y square and so on. This can be written as log of x square, log of a by b is log of a minus log of b. So all the x terms come together in a positive sign, and all the y terms come together in a negative sign, taking the negative common. So this is what I get when I rearrange the terms in the first step. y9. Log of x square, this is log of x raised to power 4 minus log of y cube. This is log of x raised to power 6 minus log of y6 and so on. So we put the terms together. Now here what we have is log of a plus log of b plus log of c will be nothing but log of a into b into c, so on. So log of x square into x4 into x6 and so on. The last term will be x raised to power 2n. 2 raised to power 1. 2 into 1, 2 into 2, 2 into 3. So nth term will be 2 raised to power. Nth term will be x raised to power 2n minus log of y cube into y6 into y9 and so on. The last term here will be, the number of terms will be n minus 1, because there is one less term than the terms of x. So the last term here will be, this is 2 into 1 plus 1. So y raised to power 2n minus 1 plus 1, which will be 2n minus 2 plus 1, which is 2n minus 1. to n minus 1. Now this becomes log of x raised to power 2 plus 4 plus 6 and so on, minus y log of y raised to power 3 plus 6 plus 9 and so on till 2n minus 1. This is an arithmetic progression. The sum of an arithmetic progression is n by 2 into 2a plus n minus 1d. 2a becomes 4 plus n minus 1 into common difference is 2. So just working with this term for a bit, we'll get 2n minus 2 plus 2n minus 2, 2a. This was 4. 4 plus n minus 1 into 2 will give us 4 plus 2n minus 2. So this becomes n by 2 into 2n plus 2. The n gets cancelled out. The 2 gets cancelled out. X raised to power n plus 1 into n is what we get. N plus 1 n, n plus 1 n, n plus 1 n, n plus 1 n. The term for x is the same in all the cases. Then we look at y. For y, what we do is we say log of y raised to power. The number of terms is n minus 1. So n minus 1 by 2 into 2a6 plus n minus 2 into 3. So this will be minus log of y raised to power n minus 1 upon 2 into 6 into 3n minus 6, which will be 3n minus 6 plus 6, so that becomes 0. So minus log of 3 into n minus 1 upon 2 y and then an n to multiply this. Now log of a minus log of b is log of a upon b, so x n plus 1 upon y 3 by 2 n minus 1, and then we take the power of n common for both the terms. So this is 3n minus 1 by 2, 3n plus 1 by 2, 3n minus 1 by 2. Option A becomes my answer. Again, I'd say this is moderate to difficult level of question. Splitting the terms and then ensuring that the terms in y have n minus 1 terms is the challenge here. So moderate, about 2 to 2.5 minutes to solve. Another way of attempting this question could be simply take n is equal to 1. If n is 1, I should get this as my sum. Now, if we put n here, x raised to power 2 raised to power 1, which is x square, so we are getting this term. Y n minus 1 power will be 0, so this term disappears. So therefore, this is correct. Here, if we put n as 1, we'll get n plus 1. 1 plus 1, 2 upon 2, 3. So we'll get y cube in the denominator, which is not true. Similarly, if we put n is equal to 1 here, we'll get y raised to power 3 by 2, which is not there in the first term. So this is also not true. We are left with a and d because n minus 1 here also will become 0. Then put n is equal to 2. Power of x has to be 2 plus 4, 6. So 2 plus 3 into 2 is 6. Power of y has to be y cube. 2 minus 1 is 1 upon 2. 3 by 2 to the power 2. Cancel, we get 3. So A satisfies n is equal to 2 as well. If we put n is equal to 2 here, 2 minus 1, 1 by 2 to the power n, which is 2, gives us y power 1. But we need y power 3. And therefore, by putting n is equal to 1 and n is equal to 2 also, only option A justifies both the answers, both the values, and therefore A is my answer. That could also have been a way of going about this question. So if we look at the overall level of difficulty for this set, I'd say moderate, 6 to 7 questions and about 23 minutes is what we're looking at. My 7 questions would be 2, 3, 4, 6, 7, 9, 10. Which are these? Not counting this one because I was not able to get this in the first click. Took some thinking, therefore not an easy question for me. Doing this, simply putting values. Here also, I think just put values and we're able to solve. This also was just a value-based question. Therefore, counting this as well. Here, we have to find the value of z, and finding the value of z may not happen in the first try every single time. So I'm not counting this as a short question. This is a standard process, therefore definitely attempting. Here also, all you have to do is apply the basic property of log of b to the base a, and then from there n cancels out, and we get a definitive value, which is independent of n. Here also some amount of rearrangement is required, and the base 0.008 may not be something that I might crack in the first try. Since I've seen something like this, it becomes easier. So not counting this as a sure shot attempt. This I think was a value-based question, would have attempted it. This one also, because if I put n as 1 and n as 2, I'll get an answer from the options, and this will always work in the exam as well, no matter how difficult the question is. All we are looking at are the small values of n, putting and eliminating options, and therefore even in the exam, if I'm not able to solve it, I will definitely put the values and get my answer. So therefore, counting this question also as a sure shot question. My attempt 2, 3, 4, 6, 7, 9, 10. From here, I'll be able to get my 6 to 7 questions net correct.